Hello guys, so I'm back again with the Matplotlib documentation reading series. I'm reading this for the first time as I've mentioned before. We completed the usage guide in the last video. In this video we're going to start with Pyplot tutorials. So yeah, let's get started. Intro to Pyplot. Matplotlib.pyplot is a collection of functions that make Matplotlib work like MATLAB. MATLAB, if you're not familiar with, is another language, and Matplotlib is sort of a way to recreate it in Python, I believe. I'm not 100% sure. MATLAB is a proprietary multi-paradigm programming language and numerical computing environment developed by MathWorks. Yeah. So each pyplot function makes some change to a figure. Example: creates a figure, creates a plotting area, plots some lines in a plotting area, decorates the plot with labels, etc. Okay. In matplotlib.pyplot, various states are preserved across function calls. Okay, so that it keeps track of things like the current figure and plotting area, and the plotting functions are directed to the current axis. Please note that the axes here are in most places in the documentation refer to the axis part of the figure and not the strict mathematical term for more than one axis. Okay, what's axis part of figure? This thing we did last time, this axis, and not this. Okay, note the Pyplot API is generally less flexible than the object-oriented API. Most of the functions calls you see here can also be called as methods from an access object. We recommend browsing the tutorials and examples to see how this works. Okay, so I'll just copy it from here. Generating visualizations with Pyplot is very quick. You can do this simply by. So I'm going to continue from where I left off last time. I'll leave a gap and let's just do this. ELT.plot this plots them, and ELT.y label some numbers. So the y label is now some numbers. You are then doing PLT.show. We've also changed certain settings here, and due to which you are seeing this other color rather than this color. So I'm not sure if how to change that stuff, but yeah, let's just go with it now. You may be wondering why the x-axis ranges from 0 to 3 and the y-axis from 1 to 4. If you provide a single list or array to plot, Matplotlib assumes it is a sequence of y values and automatically generates x values for you. Since Python starts range with 0, the default x vector has the same length as y but starts with 0. Hence the x data are 0, 1, 2, 3. So 0 was allotted to 1, 1 with 2, 2 with 3 and 3 with 4. Plot is a versatile function and will take arbitrary number of arguments. For example, to plot x versus y, you can do this. Just doing this, okay, we are getting this graph. Can we try plotting in 3D as well? I'm not sure. Maybe we need to do some extra stuff. Okay, so it rather than plotting in 3D, it made two lines for some reason. I'm not sure why, but we'll have a look at how to plot in 3D in the future. Formatting the style of your plot. For every xy pair of argument, there is a third argument, optional argument, which is the format string that indicates color and the line type of the plot. The letters and symbols of the format string are from MATLAB, and you can concatenate a color string with a line style string. Okay, the default format string is B minus, which is solid blue line. For example, to plot the above with red circles, you would do something like this. Okay, so just copying this. Yep, now we're getting red circles. So arrow is probably the thing which does this. See the plot documentation for a complete list of line lists and format strings. The axis function in the example above takes a list of xmin, xmax, ymin, and ymax. So xmin is 0, which is 0, ymin is 6, and xmax is 6, which is 6. Ymin is 0, which is again 0, and ymax was 20, so it's going to 20. So our scaling is done according to these axis values. If matplotlib were limited to working with lists, it would be fairly useless for numeric processing. Yes, because we generally use NumPy arrays because they are faster. In fact, all sequences are converted to NumPy arrays internally. The example below illustrates plotting several lines with different format styles in one function called using arrays. Okay, so let's just okay. I forget every time, so I'll just paste it here and yeah. So what this did was take values from this and point even sampling at 200 ms intervals. Okay, they haven't explained it, so let's just try to understand it on our own. So before doing that, let's just print out t. So you can see t is for values between 0 and 5 and the intervals are of zero point 0.2. Okay, so now we are plotting t against t. We are plotting t against t square and against t cube. And for the t we are doing the t versus t, the linear graph, we are doing red and this minus minus sign, blue and this square, and green and this triangular sign. So I guess we can do gs as well, and that will convert them into these signs. So now we can understand what's really happening, and now we can also make sense of what happened here. In this case, this was plotted against this and this as well. But then the graphs would have been the same, right? I think so maybe uh, let's just insert a new cell here and plot just these. I wanted these two. So there's something else going on. I am not able to understand it right now. Maybe I'll by the end of the video, or maybe I'll when we uh, read more for the documentation. Plotting with keyword strings. There are some instances where you have data in a format that lets you access particular variables with strings. For example, with numpy.rec array or pandas.dataframe. I'm not familiar with numpy.rec. Construct a ND array that allows fields access using attributes. Okay. Okay, so its array may have a data type containing field analogous to columns in a spreadsheet. An example is x int y float, where each entry in the pair is a pair of int and float. Normally, these attributes are accessed using dictionary lookups. Okay, so basically the attribute stuff from the normal Python programming which we use. Matplotlib allows you to provide such an object with the data keyword argument. If provided, then you may generate plots with the strings corresponding to these variables. Okay, I'll just copy this once again and yeah. So A is a list of 50 random values. Sorry, a list of values from 0 to 50, a numpy array. This C is a array, numpy array which has random integer values in between 0 and 50, including 0 excluding 50, 50 such values, and this rand n gives us 50 values from the random normal distribution, randomly chosen from the normal distribution, put into a numpy array. Now we have created a data B. So this data is a dictionary. Now we are creating a new keyword pair, which is data A plus 10 into np dot random dot the rand n 50 and data D np dot absolute values of data D into 100. Okay. So now we are plotting a scatter plot, and we are doing a changing the x label, the y label, and then doing plt dot show. So the graphs are different because again random values, you run it again, you will get a different graph, you run it again, you run it 100 times. You run it 100 times and you'll get 100 different graphs. You should get theoretically. There are chances that they can be same also, but those are very slim chances. Okay, so I guess we are done with this part. Plotting with categorical variables. It is also possible to create a plot using categorical variables. Matplotlib allows you to pass categorical variables directly to many plotting functions. For examples, okay, these are the names, these are the values. plt.figure fig size 9,3. Okay, plt.subplot 131, plt.bar with names values, plt.subplot 132, names values 133, names values, plt.subtitle categorical plotting, plt.show. Okay, so there is a lot of stuff going on right here. I'll go back here, copy this stuff. Sorry for the background noise, there are people in the house as well. So I'm getting these three graphs. So this I reckon I need to check out what this is. So let's just look it up. And fixed size gives us the width and height in inches. So it's setting the height of the graphs. Subplot 131 I reckon is the first, because the first one is the bar graph. 132 is assigning to the second one, and the third one is being assigned by this. I'll have to pause here for a second. I'll be back. Yep, and I'm back again. So now let's get to this part, controlling line properties. Lines have many attributes that you can set: line width, dash style, anti-alias, etc. See these. Okay, there are several ways to set line properties. Use keyword arguments. Okay, set the setters method of a line 2D instance dot plot returns a list of line 2D objects. Example, line 1, line 2 is this. In the code below, we will suppose that we only have one line, so that the list returned is of length 1. We use tuple unpacking with line to get the first element of that list. Okay, so what they're doing is they're setting line 1 with this x1 y1 and line 2 with this x2 y2. In the code below, we will suppose that we only have one line, so like this they have only one line, and using tuple unpacking they are assigning that to line. I suppose that's what they're trying to say, but right now we haven't defined any of those variables, so we won't be able to plot any stuff. Using SetP, the example below uses a MATLAB style function to set multiple properties on a list of lines. SetP works transparently with the list of objects or a single object. You can either use Python keyword arguments or MATLAB style string value pairs. So lines is equal to plt.plot this. Now we use the keyword args. So plt.setp lines color are line width this, or we can use this MATLAB style. So plt.setp where lines color are line width 2.0. Okay, so these are the list of properties available, quite a few. To get a list of settable line properties, call the SetP function with the line or lines as argument. Okay, all of this seems pretty reasonable, though we haven't tried all of these yet, but as and when needed we are getting the idea that how we can change things like line width or the symbols which are being used to plot the markers. Working with multiple figures and axes, MATLAB and Pyplot have the concept of the current figure and the current axis. All plotting functions apply to the current axis. The function GCA returns the current axis. A matplotlib.axis.axis instance and GCF returns the current figure. Okay, normally you don't have to worry about this because it is all taken care of behind the scenes. Below is a script to create two subplots. Okay, so let's just create these subplots. Yep, we're getting two subplots. So let's just try to see T1 is a numpy array, T2 is also a numpy array. We are plotting this as the first while this is second subplot. And okay, so T1 function of T1, and then T2 function of T2, and then this as K, whatever that's supposed to mean, I don't know. And this as just a cos function. Function of T is this. R minus minus gives red in these lines. So yeah, we can understand what's going on. The figure call here is optional because figure 1 will be created by default, just as subplot 111 will be created by default if you don't manually specify any axis. The subplot call specifies num rows, num calls, plot number, and plot number ranges from 1 to num rows into num calls. Okay, the commas in the subplot are optional if num rows into num calls are less than 10. So subplot 211 is identical to subplot 2, 1, 1. So right here we can see this is 211. So basically what this means is, from what we can now interpret, there are going to be two rows, one single column, and this is going to be the first one out of them. 212 says two rows, one column, and this is going to be the second one. We can try this reasoning here also. So 131 says one row, three columns, this is going to be the first one. One row, three columns, this is going to be the second one here, and this is going to be the third one here. So now we have finally figured out what that meant. You can create an arbitrary number of subplots and axes. If you want to place an axis manually that is not in a rectangular grid, use axis, which allows you to specify the location as axis, okay, where all values are in fractional coordinates. See axis demo for an example of placing axis manually, and basic subplot demo for an example with lots of subplots. We'll get to those later. You can create multiple figures by multiple figure calls with an increasing figure number. Of course, each figure can contain as many axes and subplots as your heart desires. Yeah. So let's just copy this and first try to understand this part on our Python Matplotlib depreciation warning. Adding an axis using the same argument as the previous axis currently reuses the earlier instance. In a future version, a new instance will always be created and returned. Meanwhile, this warning can be suppressed and the future behavior ensured by passing a unique label to. Okay, so it's warning that such functions might not work in a future update of Matplotlib. So we are plotting subplot 211. We are plotting this. For subplot 212, we are plotting this. These are all a part of figure 1. For figure 2, we are just plotting this, and for figure 1, subplot 211, we are changing the title to easy as 123. So easy as 123 is here, and we can read. You can clear the current figure with CLF and current axis with CLA. If you find it annoying that states specifically the current image, figure, and axis are being maintained for you behind the scenes, don't despair. This is just a thin stateful wrapper around an object-oriented API which you can use instead. Okay. If you are making lots of figures, you need to be aware of one more thing. The memory required for a figure is not completely released until the figure is explicitly closed with close. Deleting all reference to the figure and or using the window manager to kill the window in which the figure appears on the screen is not enough, because Pyplot maintains internal references until close is called. Okay, we'll have to look at close as well. Working with text. Text can be used to add text in an arbitrary location, and X label, Y label, and title are used to add text in the indicated location. So we'll yeah, copy this here. By the end of the tutorial, hopefully I'll be placing the clicking on the right place. So mu comma sigma are two variables. Mu is 100, sigma is 15. X is mu plus sigma into np dot random dot values taken from 10,000 values taken from rand n. So x is has 10,000 values. The histogram of the data, so n bins and patches. So we are doing a plt.hist, plotting a histogram which takes in x. Bins are 50, I reckon. Density is 1, face color is G, which I guess is green, alpha is something which I don't know what it is yet. X label we can see smarts, Y label probability, title, I, I think the title would also have been printed had we not run this piece of code right here, which is all messing everything up, which we did in the last part, but we get the idea. We'll get something like this. Now did grid true, so we are getting the grades. We have set the axis as well, so 40, 160, 40, 160, and that we have set the text values as well, and then done plt.show. All of the text functions return a matplotlib.text.text instance, just as with. So it's a typo here. I'll maybe fix this. Just as by contributing to the documentation, just as with line sub, you can customize the properties by passing keyword arguments into the text function or using SetP. Okay, I'll just note this line down so that I can easily trace it back in the future. Um, this is not code, this is markdown. T is now plt.x label my data font size 14 color red, so you can change these properties as well. Opinion, when you've created a data space with the x label is my data and it is red in color and the font is 14, you can say, I don't know if there's a limit, but font 400 does this. Let's be a bit over over small, bit too small, so there is something but we can't quite read it. Yep, using mathematical expressions in text, so only a little bit is left, so let's just finish it. Matplotlib accepts text equation expressions in any text expression. For example, to write the expression sigma is 15 in the title, you can write a text expression surrounded by dollar signs. Okay, if you've used some website like Stack Overflow, you'll be familiar with this type of syntax, which is used quite commonly. So yeah, the R preceding the title string is important. It signifies that the string is a raw string and not to treat backslashes as Python escapes. You might also know this if you've worked with regex expressions before. This R is used there as well because we don't want Python to treat all these backslashes as escapes. Matplotlib has a built-in text expression parser and layout engine and ships its own maths fonts. For details, see this. Thus, you can use mathematical text across platform without requiring a text installation. That's quite cool. For those who have LaTeX and DVI PNG installed, you can also use LaTeX to format your text and incorporate the output directly into your display figures or saved PostScript. We'll probably look at this sometime, a lot of time later, because I'm nowhere going near this stuff right now. I'm just taking the basic stuff. Annotating text. The use of basic text function above text at a particular arbitrary position on the axis. A common use for text is to annotate some figure on the plot. Annotate method provides helper functionality to make annotations easily. Okay, in annotate there are 2 points to consider: the location being annotated represented by the argument xy, and the location of the text xy text. Both of these arguments are tuples. Okay, so this is an annotation. I'll just, yeah, copy it, run it, and we are getting an annotated text here. I'll I'm sorry for these things. I'll probably delete that line of code or not run it in the next video. In this basic example, both the xy, so we are taking the standard stuff, the function, we are plotting the function and annotating local max this at xy to 1, and this text is at 3 comma 1 comma 0.5. Arrow props dict face color is black. Okay, shrinking it, and then we are plotting the y limits and all that stuff. Y limits -2 to 2. In this basic example, both the xy and these are in data coordinates. There are a variety of other coordinate system one can choose. Okay, logarithmic and other non-linear axes. This Matplotlib Pyplot supports not only linear axes but also logarithmic and logit scales. I don't know what that is, but I know logarithmic scales. This is commonly used if data spans many orders of magnitude. Changing the scale of an axis is easy. An example of four plots with the same data and different scales for a y-axis are below. Okay. Again, the same mistake. Again, a warning. In the future, this will raise a type error. Okay, I'll keep that in mind. So this is our order of magnitude 10 scale. This is another type of scale. This is something entirely different. So we can just look at how they made the scales. So they've taken some data and y is equal to y greater than 0 and y less than 1. Okay, they've created a sort of filter which returns only the values in y which are greater than 0 and less than 1, and then sort them. And then np.arrange, they've taken random values in the range of length of y. Okay, and then plotted it. For the linear part, you are they're setting the y scale to be linear. For the log, that is setting it to be log. For simlog, it's something different. For logit, it's something different. I don't know what these two functions are. If you want, you can comment below. I'll read them up and try to explain them in a further video, or maybe we can just look them up right here. Simlog. Um, Simlog means symmetrical log and allows positive and negative values. Okay, got it. And what about logit? Logit or log odds is the logarithm of odds where p is the probability. Okay, so this is some function. Understood. It is also possible to add your own scale using this. Okay, so right now we've covered this entire documentation, and hopefully in the next video we are now going to start from this sample plots in Matplotlib. And thank you guys for supporting this channel, and please share, like, and comment down below any more documentations you want to read and you want me to read, and try to explain as I learn them as well, because this series has been very helpful for me personally. Thank you guys once again, and peace out.